Hi there, this is Wade from VRF Education channel, and it's the second video of object-oriented programming in Python. In previous session, we took a look at the concept of object-oriented programming in general. And in this session, we're gonna check the difference between classes and objects in detail. These two concepts are totally different, but sometimes developers use them interchangeably, but it's not true. Class is just a blueprint or a template that gonna tell Python interpreter the object that you're gonna create contains what characteristics and what behaviors. The act of creating one object from a class is called instantiation, or we're gonna create an instance of a class. Object is just an instance of a class, okay? And a class just a blueprint, nothing else. Encapsulation is a general concept, and it means that we put anything that is related to an object or an entity in a real world inside a class. Their properties or fields and their action or behaviors as methods all get together inside a class, and we can access them through some objects that we created from that class. In this session, we're going to check all of these concepts. So let's go to VS Code and check these concepts in practice. Before getting dive into the classes concepts and checking the basic characteristics of classes, let me tell you the thing that I mentioned earlier. In Python, almost everything is based on classes. Even as color values such as an integer or float or even boolean, they are an instance of a class. We created those classes implicitly. For example, imagine we have a variable age and assign it to value of 20, and then I want to print the type of this variable. If I run the application, you can see the type is a class of int. Unlike some other languages such as C++, that in those languages some primitive types such as int, double, float, they are primitive type. In Python, these types are also classes. And when we just create an integer variable or a double, float, or boolean variable, we just instantiate from that class. This is implicitly and for the custom classes that we created, we should explicitly instantiate from those classes, and we will be familiar with this concept very soon. So take it into your mind that in Python almost everything is based on classes. To get a better understanding of classes and the basic characteristics of this concept that is encapsulation, how it's hard. Let me tell you an example. Imagine that we want to store students' grades for 3 different courses. So here, if we are not familiar with the object-oriented principle, we might create 4 different lists, one for students' name, and the 3 others for the grades for each student. So we might have something like this: students underline list equal to student A, student B, and student C, for example, and then db underline grades equals to 11, for example, 12 and 20, and then data structure grades equal to 20, 20, and 10, and then Python underline grades equal to 15, 18, and 20. So this approach works completely fine, but it's a little bit hard to maintain it in future. And always we should worry about the correspondent index. For example, this grade is for the first student, and we couldn't just reorder the numbers or the names. We should always get them into the same order, and it's a little bit hard for a real application to always get the things in the order. Someone might suggest to create a list of the list, and in that list, for example, we have students underline information underline list. Here we have a list of lists, and in each list we again have a couple of items. For example, student A, 11 for DB, 20 for DS, and 15 for data for Python. And it's also misspelled Python. And again, we have another list for student B, 12, 20, and 18. This way is a little bit better than the previous one, but here again, we should work with the index. For example, we said student information first, first student, and then the second entry is for the DB grade, okay, database grade. It's a little bit hard to work with index inside programming languages. We always prefer to work with enumerations or even the text labels. So this is not a good approach for real application again. It's a temporary solution. Another approach is to create something with combination of dictionaries and lists. It's a little bit better. We can get rid of these index, for example, and create a dictionary based on the student's name or ID, and then assign their values again in the list. It looks like something like this. For example, student information list 2 equals to something like this. For example, student A, a list of numbers, student B, now if I want to access the database grade for the student B, I can just use this approach. Student list 2 for the student B, I want the database is the first entry. So this is a little bit better, but it also have some complexities. Again, for the numbers we have indexes, and maintain it in a long time is very difficult. So imagine this approach, but we are not going to create some classes here, but what if I have some classes for a student? For example, A is a student, something like this. I want to create student. I want to create an instance of a student class, and I will tell you how to do it very soon. And now A dot, for example, a name equal to for example, Vahid. A dot DB underline grade equal to 10, for example. A dot DS underline grade equal to 20, and A dot Python grade equal to 20 again. Great. So this A could be something meaningful. For example, I can change it with the student name. For example, Vahid. Something like this. Now, every time I want to access to the information of Vahid, I can just use it and then go to the attributes or properties of this specific object. This is much more readable than the other approach. For example, compared to this one or this one. This is much more readable, and you can debug it much more clearly than the other approaches. It's very good look and feel, and you can maintain it in the long term. This approach brings us one of the object-oriented concepts, encapsulation. Encapsulation means that you get together everything that is related to an object inside it, and then you can access it through a dot notation. Okay, every attribute or methods of an object can be accessed through a dot notation, and it's generally related to that specific object. We encapsulate everything that we need inside something. Okay, we have two different concepts here, classes and objects. These are used interchangeably by programmers, especially the one that is just start to learning object-oriented, but they're totally different. Let me delete all of these codes. Oh, let's comment them. We don't need them. We have something named classes, and the other one objects. Objects. Okay. Class is nothing, just a blueprint. Okay. This is a class definition. Student. Okay, we don't have it, and we will call it, we will create it very soon. A student is a class, a blueprint, a template that's gonna tell the Python interpreter that when you create an instance of this class, for example, Vahid in this example, you can have these fields inside that specific object. So objects are an instance of a class. Imagine that in a real world, human in general is a class, and we all are an object or an instance of a human. Human is just a blueprint. When we call something human, we expect something with two eyes, for example, two ears, one nose, two hands, two legs, and any other stuff related to a human body. And when we create an instance of a human, we create something like Vahid, for example, John, Sarah. These are specific and individual instances of human class. They are objects, individual objects that we can work with them. So this is the difference between classes and objects. Classes are the blueprints, but the objects are instance, something that get realized based on that blueprint. Okay. First, we need to define classes, and then after that, we can create objects. So this is the a rule of thumb. We first should create classes and then create objects, and working with objects. We generally don't work with classes. Sometimes we can define something inside classes that is common between all the objects, and we will talk about it during this series. But most of the time, we work with the things that encapsulated inside the objects. Okay, they are assigned to objects, and each object has its own value. For example, when I create an instance of a student and call it Vahid, I can here again create another instance. Let's comment it. For example, Sarah, student. Now, Sarah dot, for example, name, for example, Python underline grade equals to 90. These two objects, Sarah and Vahid, are the same from the structure point of view because we built them using the same blueprint, the student class. The structure is the same, but the content is different. Each one has its own memory space, and their values are separated from each other. Sarah has the 19 for the Python grade, and Vahid has the 20 for the Python grade. So they are completely isolated in the memory, and changing in one object doesn't affect on the other one. Now we checked a couple of attributes or fields in the objects. Imagine that we want to model a point on the Cartesian space. Okay, we might create a class called point. I'm sorry. We might create a class called point and create an instance of it. So each point again has some attributes. For example, the x and y coordinates. P.x equals to 10, P.y equals to 100, for example. Now each point has some behavior or some methods. For example, we can call a method p.draw. Draw is a behavior for a point. We can draw a point on a screen, okay? Or we can move it, p.move. Move is another method or another behavior that is related to the point class, okay? These are the methods that we should define for each object. These are the behavior that we can get from one object inside our application, and we will talk about it deeply very soon. So now let's check how we can create a class inside our application. To do this, we should use a very simple structure. To create a class in Python programs, we need to use a keyword class. This is just like other programming languages such as Java or C# or C++, and etc. And after that, we should choose a good name, a proper name for our entity in our application. For example, if we want to create a class for a student, we can just use a student as the name of class, or customer, clerk, check sheet, checkbook, anything that we get familiar in the previous session. We can use any name until it follows the naming rule of a Python interpreter. But it's better to choose a proper and related name to the entity in the real world. For example, we want to model a point inside a Cartesian environment, so we choose point as our class name. Okay, point. And by convention, we use Pascal notation for naming classes inside Python. In Pascal notation, we should write the first letter of every word in capital. For example, if our class, let's change it to check sheet. You can see the C and the S. These are the first letter of two words. They are in a capital case. So this is Pascal notation. So let's change it to point one more time. And after that, we need to put a colon. And again, here, just like any block for functions, for loops, we can just use pass. This is the simplest class without anything inside Python. And it's somehow useless, but we just use it for the demonstration purpose. And we can add some other things in the first line. We will talk about it in future. Now let's add one behavior to this class. We want to draw it on the screen. So we said the behavior is equivalent to method in Python programs. So we can just use method definition inside the class. It's inside the class, okay? Draw, parentheses, and then colon. And here we have some console application, so we just print it on the screen. Draw is called. And this is the first behavior of the point class. Now, how can I use it? If we run the application, nothing happened because we didn't do anything. We just create a template for our object. It's a blueprint, as I told you earlier. Now, if I want to create this class, I need to create some instance from this class. So to create an instance, we can just use a name for our instance, and again equal to the class name. Here it is point, and then open and close parentheses. This is the simplest way to create an instance of a class. Now I can call the draw for this particular object. And I forgot to tell you, every method that is a behavior for an object should have at least one parameter, and by convention we call it self. Okay. In all classes, in all methods inside a class, we have one parameter for the methods, for the instance methods, not the class methods. We will talk about class methods in future. These are instance methods that we can call through instances. For example, I here can call p1.draw. Okay. So what is the self? The self is related to the object that the draw is called over. Here self is equal to p1. P1 is automatically sent as a parameter to the self. And if you're familiar with object-oriented in other programming languages such as C++ or C# or Java, this is a little bit weird, because in those languages we don't need to pass the instance as a parameter to the method. But in Python, it's necessary to create at least one parameter, and this is the object that we want to call the method over that. This is the P1 here. Or if I just create one other object, P2, point2 equal to point, and P2.draw, we call the draw method here. And again, this is another instance of the point class, and when we want to call the draw method, in this time, self is equal to P2, not P1. Here is equal to P1, and here is equal to P2. And we will talk about it in detail in future. So, if I run the program, you can see the draw is executed. And this is just a static message. If I just get back the P2 instance and run it, you can see we have two methods written in the screen on the console. Okay. I need to do something. Let's print. Let's get rid of this one and print type P1. Let's see what we have here. It says that P1 is an instance of a class named point that is defined in the main module of the program. This is all the information that we can use from the type method. So this is a class, instance of a point class located inside the main module of the program. And another method that we can use is instance. For example, I can say print is instance point P1 and point. I'm gonna check that if P1 is really an instance of a point or not. This is true. Yeah, it's really an instance of a point. If I change it, for example, to int, this instance is not, this object is not an instance of an int class. If I run it one more time, let's, here we have false. It is not an instance of the int class. And this function will be very useful when we are working with polymorphism and something like that, and we will talk about it in future. Okay, this method is very useful for us, that we can check if one instance, if one object is an instance of a class or not. When we use inheritance, it gets more handy for us. And this is all about classes, basic classes in Python. And let me tell you something else. If I just write P1 and press dot, here is the draw method, and there are a couple of other methods here. Okay, they are prefix and postfix with dunder or double underscore. There are some special type of methods in Python, and we're going to talk about them in future. They're very useful, and we can use them to enrich our classes to do some operations very easily that we should do in other programming languages with a lot of coding. Okay, we'll talk about it in future also. So this is the basics of classes and objects in Python. I hope you enjoyed the content of this session, and we will talk about other aspects of object-oriented in the next session.